Okay, it's time for our quiz over this lesson on minerals. So, question number 1, the exterior form of a mineral reflects the internal arrangement of its atoms. So, atoms are inside of minerals. Number 2, a particle which exists in the nucleus of an atom and has no electrical charge is called a neutron. So the protons were positive, the electrons were negative, and the neutrons were neutral. Question number 3, how many electrons does the element uranium contain? Well, you can't answer this unless you've got a periodic table. So get out your periodic table, look for the letter U on there, and you'll see that it's got a 92 and it's got a 238. So which one do we want to go with? Okay, we want to go with the atomic number, so that's going to be 92, which is the number of protons, and for every proton there is a electron that goes with it. So that's how you kind of reason that out in your head. Number 4, which force holds the atom together? That would be the electromagnetic. Number 5, magnesium is located in the second column of the periodic table. What does it want to do with its electrons? So if it's in the second column, how many electrons does it have? 2 outer electrons. What's it trying to get to? What's the magic number? 8. So what could it do? Either give away 2 or it could take 6. So which is going to be easier? Giving away 2. So it wants to give away 2 of its electrons. Number 6, an example of covalent bonding. So remember there was covalent, ionic, and metallic. So which one is the example of that? Okay, that would be water. What would B have been? Table salt. That's ionic, and then copper's a metal, so it's metallic bonding. Number 7, which of the following is not included in the definition of a mineral? Okay, so it's going to be the unordered internal structure, because minerals have an ordered internal structure. Number 8, name one way that a mineral forms and one way that a mineral can be destroyed. So we said, for example, that a mineral can form when it freezes out of a melt, like magma or lava. A way of destroying it would be to heat it up, and then it turns back into a liquid. Another way of making one was biological. Another way of destroying one was biological. So another way of making one was called diffusion, where the atoms would move one atom to the next, and that would alter the internal structure of the mineral. So go back to that one slide that talked about the how minerals can be created and how minerals can be destroyed. Which one of the following is not a property used to identify minerals? This one's kind of tricky. It's actually texture. So we're going to use texture to identify rocks, not minerals. So we use the hardness, the streak, and the crystal form for minerals, and then we'll use the texture thing when we're identifying rocks in our next lesson. Which of the following is the hardest? So what you need to do is go to that hardness scale and look for which one is the hardest, and it's going to be corundum. So corundum is actually used in sandpaper because it's so hard. What are the cleavage angles of this mineral? So that is halite, and it turns out that they are going to be cubic, so they make a 90-degree angle. So not only with halite, halite has a crystal structure that's a cube, and it also has cleavage planes that make a cube as well. So if you were to take salt and you hit it with a hammer and look at the shards underneath a magnifying glass, you'll see that they're little cubes. Number 12, the most abundant element in the crust of the earth. All right, so we talked about what the silica tetrahedron was. Okay, so that was this thing here. So you can tell which one has to be the most abundant because there's 4 oxygens to every silicon. So that means oxygen is more abundant than what the silicon is inside the earth. Number 13, the ratio of silicon atoms to oxygen atoms is the same in each of the various silicate structures. That's false. So the ratio in this one would be 4 oxygens to 1 silicon. But if you make a string of them, then notice that you're eating up the oxygens. So I have to take off this oxygen in order to attach it to this one. So when I make a string of them, it has less oxygen compared to the amount of silicon in there. So the different kinds of silicate minerals have a different ratio of silicon to oxygen. Which of the following ores is a source of aluminum? And that's going to be, well, you have to kind of look it up, but it's bauxite. So the mineral bauxite is going to be where we get, well, actually bauxite, it's a sedimentary rock, but it's the result of weathering of a mineral. Anyway, bauxite is the ore where we get aluminum from. All right, and there you go. So that was a very long lesson. Sorry about that. And in our next lesson, we are going to start talking about rocks. And so I will see you then.